Welcome, this is your 5-minute geography lesson. We're covering Theme 3, Element 4, Physical Volcanic Risks. Quiet please, I'm Mr. S and I'll be your 5-minute teacher. Physical volcanic risks are those that are created by the hazard themselves. There are 4 main physical risks that are associated with volcanic eruptions, and these include pyroclastic flow, ash clouds, lahars, and lava flows. So let's dive right into it. So you can see I've got a diagram and I've got our associated risks displayed around them. So let's start in the top left hand corner with lava flows. So a lava flow is a stream of molten rock that's come out of the mantle during the eruption, and that can flow either slowly or quickly depending on what margin we're on. If it is a constructive margin, then these flows are going to be very, very quick, and they're probably more of a hazard or a risk to people because they have the potential to move faster. At a destructive margin, the lava is thicker and slow moving and probably doesn't really get off the volcano itself, the sides of the mountain itself, so in which case it's going to pose less of a risk. Lava flows tend to cause more of a risk to the environment than they would do to mankind. Moving further down, we have lahars. They're often called mud flows, and they're a combination of water, rock, ash and sand and mud. Essentially, when a volcano erupts, because stratovolcanoes tend to be quite tall, more often than not they will probably have a snow peak on them, so there'll be some water up there. When the eruption occurs, that snow melts, it mixes with the ash and the material on the side of the volcano to form this really fast moving mud flow, the lahar. Now that doesn't sound very dangerous on its own, but if you direct your attention to this photograph, you can see the volume of mud that's actually produced. These are 2-story tall buildings, and it's actually covered the entire building in mud. That's how deep and how deadly they can be. We then have ash clouds. Ash clouds are the rock and particulate that's been expelled into the atmosphere during the eruption, usually part of the cap that was once blocking the vent before the eruption. It gets drawn up into the atmosphere and circulated by the prevailing wind. So in this case, this ash cloud has been directed in this direction because that's the way the wind's blowing. Depending on how much ash is expelled and how strong the wind is, it can travel hundreds and hundreds of kilometers in distance. It blocks the sky and the sun, so that can kill crops when it falls back down to the ground, or it can collapse roofs because the ash is actually really, when it starts to fall, puts a lot of weight on the roof and it collapses the building. Or it can severely disrupt travel, including international flights, because planes can't fly through the ash because it interferes with the turbines and can shut them down. It stops the air from getting in. So ash clouds can actually have an international or global impact. And then finally, perhaps arguably one of the most deadly risks from any volcano is pyroclastic flow. And this is a superheated cloud of ash and rock fragments and gas from the volcano that can travel between 160 to around 250 kilometers an hour. So in some cases that's faster than a plane. And if you're caught in that, you'll die before the ash cloud hits you, because the gas in front of it is so warm that when you breathe it in, it'll melt your lungs. And we've seen examples of what this can do in history. If you think about Pompeii, Mount Vesuvius erupted, a pyroclastic flow covered the city of Pompeii, and we've still got examples today of people stood in place covered in ash like statues because of that pyroclastic flow. If you're anywhere near the volcano, the likelihood of actually being able to outrun it is severely reduced, almost impossible, because you have to go at least 250 kilometers an hour to escape it, and the temperatures are over 1,000 degrees. Well, that's it for today. Try it now task for homework. Class dismissed.